this lesson, we're going to reinforce what you learned about graphing quadratic functions. So here we have a 5 by 5 grid with the x and the y-axis labeled, and here's our quadratic equation, or our quadratic function, 6x squared minus 12x plus 4. We don't just randomly want to start plotting points on the graph. We want to make sure that when we make our graph, we include 3 very specific points. And one of them is that vertex, that turning point of the parabola. So first we need to find it using the formula you were given in class, that the x-coordinate is the opposite of b over 2 times a. So we would do the opposite of negative 12 over 2 times 6, giving us 12 divided by 12, which is 1. That's going to be our x value of the vertex. Now we need to plug the x in to the equation to get the y value. So we'd have 6 minus 12 plus 4, giving us a negative 2 for our y value. Feel free to use your calculator for the arithmetic if you need to. So then what we're going to do is plot that vertex, 1 to the right on the x-axis and 2 down on the y-axis. And that's our turning point or our vertex. That's the most important part on that parabola. So when we have that vertex plotted at 1, negative 2, the next wise thing to do is just draw a really lighter dotted line through that vertex, a vertical one. This is called the Axis of Symmetry. It's the splitter. It's kind of like the spinal column of the parabola. We'll have identical mirror images to the left and to the right. So we now need another point. And for your other point, what you're really going to want to do is use 0 because it's so easy. When you plug 0 in for x, all the first part, the ax squared plus bx, will disappear. And you'll just get that last number over there, or that 4. So 0, 4 will get plotted here on my y-axis. It's called the y-intercept. Next, we need to get another point. We're going to use that symmetry. We're going to walk to the line of symmetry and then walk away the same distance. So you can see on the graph, I'll go 1 to the axis of symmetry and 1 away, and I'll have my third point. So that gives us our 3 points that we need to find. We connect them. We put arrows on the ends indicating they go on forever. And then we're going to be asked to find the domain. And in your notes, you should have written the domain is what x can be. And for parabolas, there's no restrictions. So we say all real numbers. But the range is what y can be. And you'll see that parabola turns at the vertex. So it's always above that vertex. And so we would say y has to be greater than or equal to negative 2. It's always going to be the y value of that vertex that's going to determine your range. If this had opened down at the vertex, then we would say y less than or equal to negative 2. But that y value of the vertex is in control of the range.